GCSE question of the week, week 17, higher tier questions. Okay, so show that the perimeter of this isosceles triangle is 49.5. And just to reinforce that it's an isosceles triangle, we've got these two lines here, just reminding us that those two lengths are the same. Those two sides are the same length, rather. Okay, so that's going to be key to getting started, I think. Okay, because we know that 4x plus 2 must be equal to 6x minus 5. And we've only got x's in that equation, so it looks like we should be able to solve for x. So I'm going to take away 4x from both sides, I think. It's going to give me 2 equals 2x minus 5. And then I'm going to add 5 to both sides. It's going to give me 7 equals 2x. So if 7 is equal to 2x, if we divide both sides by 2, we're going to get x equals 3.5. Okay, so x is 3.5. We can now plug it into those three sides. So let's do side 1 first. So side 1, call this side 1. We're going to get 4x plus 2. Well, we now know that's equal to 4 times 3.5 plus 2. Don't need the brackets, but let's put them there. And what do we make that? 2 times 7 is 14, plus a 2, I make that 16. Right, 2. Now, we know that we're looking for 6x minus 5, side 2. Now, presumably, that's got to be the same as side 1. So it should be coming out of 16, but we better just check. We want 6 times 3.5. Take away 5, subtract 5. So 6 lots of 3.5. Well, 3 of them are going to be 10.5. Double that, we get 21. Take away 5, we do indeed get 16, which is good news, otherwise something would have gone wrong. And side 3. Side 3, we've got 5x. And we know that's 5 times 3.5. So I'd be tempted to multiply by 10, that gives me 35. Half that, I get 17.5. So fingers crossed, 16 plus 16 plus 17.5 better give me 49.5. So we've got 0.5, we have 19, and we've got 40. Bingo. Okay, so looking good. The perimeter of the triangle is 49.5. Done. Okay, number 2, a ratio question. Given the ratio a plus b to 2a minus b is equivalent to 2 to 3, show that a equals 5 thirds and b equals 1/3. I should put those in as fractions, sorry. Now, as soon as it says show that, some people are always tempted to substitute those values in. Right, we can't do that. If we're trying to show that a is that and b is that, we've got to get to that as our end point without using those values. So we know what we're aiming for, we can't use those straight away. Okay, what we can do though is say that, well, a plus b to 2a minus b is equivalent to 2 thirds. So let's let a plus b equal 2, and let's let 2a subtract b equals 3. Okay, and it looks like we've got two simultaneous equations. We've got a's in, we've got b's in each one. And we've got plus b in the top one, we've got minus b in the bottom one. So if we add those two equations, we should get 3a equals 5. And divide both sides by 3, that gives me a equals 5 thirds, which is looking good. That's what we want. Okay, so how are we going to get b? Well, there are lots of ways we could get b. We could substitute into either of the equations above. Let's choose a plus b equals 2. So we'll start with a plus b equals 2. That's the simplest one. We now know a is 5 thirds. So 5 thirds plus b is equal to 2. So b is equal to 2 subtract 5 thirds. Or if you prefer, b is equal to 2 subtract 1 and 2 thirds. Okay, which perhaps makes it clearer that 2 subtract 1 and 2 thirds, we just have 1/3 left. Okay, so b is equal to 1/3. Done. Okay, question 3. G is inversely proportional to the square root of h. Okay, so as soon as we've got something's proportional to, something's inversely proportional to, okay, you need to know the steps for solving these. So G is inversely proportional to. Now, if G was proportional to the square root of h, we could put something like this. G is proportional to root h. Okay, if it's inversely proportional, that means that G is proportional to 1 over root h. Okay, so that's the same thing as saying G is proportional. Sorry, that's the same thing as saying G is inversely proportional to the square root of h. So if it's proportional, okay, don't need the 1 over. If it's inversely proportional, we need that 1 over. We need the reciprocal of that root h. So we're set up. Now, rule next is that proportional really means it's equal to some constant times 1 over root h. So we can write that in symbols as G equals some constant k times 1 over root h. And it's much less messy to write that as G equals k, the constant, over root h. So they're always your starting points with these. So we've got G equals k over root h. We've got an equation. Now we can substitute the values they give us. And they'll always give us a pair of values so that we can now work out what k is. Okay, that's always your first job when you've got your equation. So we've got G equals k over root h. We're now going to plug in G is 15 equals k over root h is 25, so root 25. Okay, so 15 is equal to k over root 25, which is 5. We don't need to worry about the plus or minus here. We'll just take the positive root. So k is equal to 5 times 15. So I would multiply by 10, get 150, half that, 75. So k is 75. So now we know k, we can find the value of G when h is 16. So we'll start with our equation again, which is G equals k over root h. But we now know k is 75. And we can substitute h is 16. So we want root 16. It's going to give us G equals 75 over 4. Again, we'll just say the positive. Okay, so we could halve that, halve it again, or we could do some long division. We want 75 divided by 4. So 4's into 7, carry 3, it's supposed to be a 3. 4's into 35, 8, 3 to carry. 4's into 30, 7, 2 to carry, 4's into 25. So G is equal to 18.75. Done. Given y equals 4 sine x plus 1, find the exact value of y when x equals 60. Okay, so the fact that it's asking for sine x and when x is 60, sine 60, and the fact that it's saying find the exact value, and the fact that it's a non-calculator question is prompting me to think we're going to need our exact trig ratios. And you're either a learn them kind of person or you're a derive them kind of person. And for me, it's a quick derivation. So if I want to get my sine or cosine or tan of 30 and 60, I think, how do I get an angle of 60? I make an equilateral triangle. Okay, so I've got my equilateral triangle, and I'm going to divide it into 2 right angle triangles. So that must be 30. Then I'm going to name my side lengths, and so I can make this side length 1, really, and make this 2. Let's make that a bit clearer. So each of the sides of the equilateral triangle I'd make 2, because we've halved this one here, that must be 1. And then I can use Pythagoras to tell me that this vertical height in the middle is root 3. So I'm doing 2 squared is 4, subtracting 1 squared, which is 1, I get the square root of that, root 3. So that's the little triangle that I need. Okay, now we don't need it for this question, but if I need to derive 45-degree angles, then I think, how am I going to get a 45 degree? Well, I need a right-angled isosceles triangle. Okay, that way this is going to be 45, this is going to be 45. And how do I do that? Well, as long as these two side lengths are the same, simplest we can make them is 1. So I've got my two side lengths of 1. This time I've got 1 squared plus 1 squared plus 2. This is root 2 by Pythagoras. So they're the two triangles I need. Okay, and then I can derive sine, cosine, tangent of 30, 60, or 45. And 0 and 90 should just know, really, from the graphs. Okay, so what do we want? We want sine 60. So we really need to know sine 60. So sine, to the jump, sine 60. So we're going to use this triangle here. We're looking from that angle, and we know that sine of some angle is always equal to opposite over hypotenuse. So from that 60, that's looking like root 3 over 2. So done. Sine 60 equals root 3 over 2. So that's the hard bit done. Y equals 4 sine 60 plus 1. Therefore y equals 4 times root 3 over 2 plus 1, which equals 4 root 3 over 2 would have been much neater in the first place, plus 1. And we can do a bit of simplifying because that's the same as 2 root 3 plus 1. Okay, if you prefer, we could cancel something like that. Okay, but the 4 divided by 2 is just going to give us 2. So y equals 2 root 3 plus 1. That's the exact value. Done. Good luck in your mock.